Pretty similar to the steps that we had to do to find the equation of an exponential function, okay, where you had to do it by hand. Okay, and so I'm going to give you 2 points. Okay, they may or may not actually show up on your graph, but hopefully they do. But I will provide you with the coordinates. You don't have to guess what they are. Okay, and so when you set up your equation, the first thing you need to do is know what your general form looks like. So the general form is going to be some multiplier in front of the log. Here, because we're just using common log, you don't have to put a base of anything. It's just an unwritten base 10. And then you're going to have x minus some value c plus or minus some value d. Right, so this is kind of what I'll use just as my general form for this. So my first step is going to be plug in the information you know from your vertical asymptote. So you can see, you can kind of barely see it, but it's in a blue dashed line here. What is our vertical asymptote in this problem? You see that the vertical asymptote is x equals -1. So that information is your c value. Okay? So this is going to be input in your c. So we can then get our general equation to be a times the log of x minus 1 becomes x plus 1 plus d. So that's the first step, is you can apply your vertical asymptote information. Right, next what you're going to do is you're going to plug in 1 point. Okay, more than likely what I would choose is I would choose the point that's closest to your asymptote. Okay, so in this case, I'm going to choose this point 0, -8. And when I sub in that 1 point for my x and my y, what I wind up with here is -8 is equal to a times log of 0 plus 1, which is 1, plus my d value. Okay, and what you can see here is what is log 1. My input is 1, so 10 to what power equals 1? 0, right? So that means that this is 0 times a. This allows me to find d. So this is a whole value of 0. So those all cancel out, and I get d is equal to -8. So right now I have the form y equals a times the log of x plus 1. My b value is, or my d value is -8. So the final step is to plug in my other point. And the other point in this case is 9, -3. And when I plug that in, a -3 for y, my a value, my 9 plus 1. And here when I evaluate, 9 plus 1 is 10. Log of 10 is 1. When the base of the log and the input are the same, it has a value of 1. So this is going to give me -3 equals a minus 8. Add 8 to both sides. I get a is equal to 5. And then I finally have my last piece of information. So I can write my equation is 5 times log x plus 1 all minus 8. Okay. Look at this sort of progression of how you can develop your answer. So the first thing we're going to do is we're going to apply our vertical asymptote. Okay, so the vertical asymptote, which is at x equals what? -2. So that's what plugs into the c value. So we get a times log of x minus a -2 plus d. So there's the first progression. And then we're going to work from here, substitute in one of our points. I'm going to choose the point that's closest to the asymptote. It's also going to be the point that gives me a value of 1 inside. So if you're looking at like why choose that point, I want the value to be 1 in here because that will cancel my log out because the log of 1 is equivalent to 0. So if I plug in my -1, -6 here, I get -6 equals a times the log of -1 plus 2 is 1 plus d. This has an overall value of 0, so I get my d value to be negative 6. So my next progression, I have my x plus 2, and now my d value is negative 6. And so my final step is to plug in my other point, here 8, negative 8 in this case, and solve for a. So when I plug in my negative 8 output, a times log of 8 plus 2 minus 6. And when I simplify this, 8 plus 2 is 10. Log 10 of 10 has a value of 1. So again, the a stays, but this is just equivalent to 1. So if I add 6 to both sides, I get my a value to be negative 2. And that gives me my final solution here, which is negative 2 times the log of x plus 2 all minus 6. And that would be my solution.